Hello, everyone. How are you guys doing today? I hope you're doing well. Code Bara, hello. Okay, I hope everyone is doing fine. If you ask me, I'm good, thank you. Um, Here is not behaving as you as always, doing weird things. It doesn't matter. Anyways, I hope everyone is doing well. Mm. And yeah, welcome to a Thursday. Welcome to a Thursday of another session with our memory allocator. It's been a while. The memory allocator has become, if anything, one of our, best friends. It's a little, a regular on the channel. It's like, has become a family member at this point. But yeah, welcome everybody. I hope you're feeling well. I hope you're feeling fine, well rested, especially. Sleep is very important. For those of us here in the US, for those in Europe, I hope your day went well because you guys are kind of like 5 p.m., 6 p.m., maybe. Um, but yeah. I hope everyone is feeling well. And there's no better way to start the day than to take a look at code. Hello, Ganga Kamal. Hello. So we're gonna start the day. We're gonna start our usual session. Um, yeah. I just want to know how are you guys? How are you? Um, in the meantime, I'll let you know some things that happened yesterday. Um, Basically, I tried working on our memory allocator in the evening, uh, as I promised, because I said I was gonna, replace all the calls to the red black tree, and debug some things because they were kind of annoying. And because I recognized that like debugging is not the it's not the funniest or like best thing to see on a stream. And so yeah, I tried fixing things yesterday and indeed fixed them. So today I'll just show you guys sort of what the fixes were so that you can know what happened but don't have to go through the mental pain of following what actually happened. Anyways, so basically, basically, um, let me look at it. I'm trying to find something. There you go. Okay, I'm trying to find the fixes. Um, Perfect. So let's change to the coding scene. Hello. And yeah, so I'll explain some of the fixes, no, all of the fixes that were made, which were basically these, right? I guess it's better if I just have it in a narrow window, right? Because I can go back one by one. So this is the moment where we convert the red black tree to an intrusive data structure. And then we needed to change sort of multiple places in order to accommodate for this. Hi, Penguin operator. And yeah, so we needed to, as I said yesterday, like fix some things. I debugged for a while in the evening. And what ended up happening is there were multiple things to fix. There were very small details that were there just because we changed a little the mental model, and so there were some things that we didn't translate perfectly. Um, so an example of that, right? We refactored the arbitrary, right, to be an intrusive data structure. That's fine. Then, right? Oh, why does it say the same? What the hell? Oh, what is this? What? Okay, the console is just Penguin is here. I agree. So yeah, so let's do git log, and you'll see the fixes. I think these are the fixes. Okay, perfect. So first fix was this one. Fix an insertion error and ghost node offset error. So it says The assertion error was isValidBlock was checking whether the block is out. So I'll show you exactly what I mean by that. If you go to the isValidBlock sort of check, right? I think it was here. In this line, rather than min heap high, because this line is checking if the last byte of the block is within the heap, right? And so it just calculates where the last byte is, and it calculates that it's smaller or equal to the highest byte in the heap. This, instead of being high, it was low. So it would always trigger the assertion, right? Because any block is going to be, its last byte is going to be outside of the lowest byte in the heap. So that was the assertion error. And the ghost node offset error is that because of our new red block tree, the ghost node doesn't exist anymore. We may bring it back just for the sake of, going branchless on some stuff. But for now, it's not there. It doesn't exist anymore. So small parts of the program would get their offset messed up, right? Because some of them were relying on the fact, especially print heap, that the ghost node existed. So print heap did it because it knew that it needed to print a heap, but the ghost node, it's not part of it. And so it would just skip the ghost node. Now that the ghost node isn't there, it didn't have anything to skip. And so anything it printed would be like super weird. The next fix was in arbitrary insert, metadata would not be cleaned before appending insertion. And this is something we had in our previous version. We just forgot to do this time. So I'll tell you what I mean. Let me go to arbitrary insert. So I think we have here. Arbitrary find, arbitrary insert. There you go. So we need some nothing metadata, right? This thing is here because whatever block they give us may contain user information, right? And remember that user information can interact with the metadata because we don't care about the metadata, so we just give it to the user. And when we give it to the user, it messes up a bunch of stuff. And so before, without these lines, what ended up happening is this node, we would try and find the place for insertion, and then we would just, link it with whatever the parent was. The problem is that you linked this node, right? So what would end up happening is the metadata was completely bogus, completely, it could have been anything. And so when it linked things, it would update information based on that metadata. But the metadata is just completely arbitrary, which would make everything fail, right? So for example, since this is linking them together, if node had, according to the erroneous metadata, a parent, this thing would try and go tell that parent that node is not going to be, it's no longer going to be its child, it's going to be current node's child. But if it goes to some random address in memory and tries to do that, then first of all, segfault. Second of all, if it falls within the heap, then we get corruption of a bunch of stuff. And so for that, that is the reason why we need to clean the metadata before we even consider insertion, right? So that was the other error. Other than that, we had nothing else, right? So I did some refactoring and I improved the fuzzer interface to say, ooh, Chocolate Chicken 69, welcome. Welcome to the stream. Yeah, I'm explaining some of the things I did yesterday evening. So yeah, after those fixes, I simply wanted to, refactor, sort of improve the fuzzer interface a little, and you'll see what I mean by that. The fuzzer is now called fuzzer.c rather than mmtestrandom. So I feel it's a better name, right? Fuzzer. And I added some command line arguments. So I'll show you what I mean. If you compile the program. Hello. Oh, this is not better. Oh, there you go. Better. Okay. Let's reset. So now if you run the program, you say /fuzzer, right? Then you can now pass command line arguments, right? And for command line arguments, you can do something like, right? So Dash n is for the number of operations that you want performed. So say I only want 10, then it only performs 10 operations. So it's 0 to 9. And now if I pass 100, you'll see that it does 99. Like it goes up until 99, which is 100. And so yeah, we have now command line arguments. You can also set a specific seed. So the seed is, I don't know, the number 126. And notice that every time I run it, the same output is going to take place just because it's using the same random seed, right? So that's great. I also have a parameter for the max size of the heap. So if you want the heap to only be 100 bytes, then you can do that. Of course, it's gonna segfault if you do. But yeah, right? And so that's it, right? That's an improvement on the fuzzer. Now it's way easier to utilize it. And you'll see that the code is a little bit more organized, right? If you want help on the commands, you can do fuzzer help. And then, yeah, run something you want. That should 10. Now it has this little title, right, that tells you what the seed was, the max heap, and the number of operations. So yeah, that's the improvements on the fuzzer. You can take a look at the code both here in the stream, I guess, but also on the GitHub if you want to take a look at what I changed. But yeah, so this is the main fuzzer, etc. All right. That being said, I think there are no more changes, right? Improve the fuzzer interface. This was just some random file that we had, and I'm like, okay, let's delete this. This was a fix in the fuzzer that I just created. Oh yeah, so I refactored things to use size t instead of uint32, just to support, multiple architectures. It's like a very, naive or basic way of saying not everything is 32 bits. You could be in a 64-bit system. Sure, reorganize. Oh yeah. Red Black Tree was in the SRC folder, and now that it's an intrusive data structure, it can go in containers, right? And so I just moved it there. Finally, I think I updated the makefile, right? I'll update the makefile to account for all of these organization things that were changed. And the last thing was a fix in the fuzzer to allocate information not in the stack, right, to prevent the stack overflow. So what ended up happening is if you call, give me a second, if you call the fuzzer with like a very big number, notice that the fuzzer allocates that many blocks. Give me a second. Here. It allocates that many blocks for the stbag, right? So same here, right? Number of operations times the size of block. And so with this thing being very big, this array, the way it was declared was a normal array, the one that you just do this, right? And then you put a number. So it was stored in the stack, but the stack is, it's not a representation of infinite memory. And so what we ended up having was put this in the actual heap so that it can grow way past the limit that macOS imposes on the specific what's the name? The specific size of the stack. There you go. Possibly Rishi, welcome to the chat, and hello. Say, I was searching you on YouTube. Is this your account? At SharifSegfaults. That is one of my channels. Yes. Why? I haven't looked at that channel in like years. Well, not years, but like in a while. But yeah, this was me a while ago. That was like very old, but more like 3 years ago. Yeah. That's indeed the same person. All right. So here we have, all of this stuff. Yeah. So those are the improvements. Those are the things that have happened. And so you can see that currently it's printing some stuff. If we go to the fuzzer and then remove these random printfs, so So if I search for printf, 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 printf. Oh well, this one I don't want to delete, and this one not. This one not. Okay, so if we now compile, you'll see how we can sort of have a feel of the memory allocator, and I'll show you that the fuzzer doesn't flag any errors, which means that we can have a high degree of confidence that things are well. 10 are done immediately. 100 operations also immediate. Well, not immediately, right? But like there is no noticeable difference. 1,000 the same. 10,000 really fast, right? 100,000 still pretty fast. If we do 1 million operations, right? It's like 2 seconds. Like 1, 2, 3. Well, 1.5 seconds, right? It's like 0, 1 to a half, or more like 1.63 seconds. And then if you do 10 million, which I think is this number, 1, 2, 3, 1, 2, 3, 1, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There you go. So around 16.5 seconds. Which, I mean, we're doing, 10 million operations, but this, in my opinion, is extremely slow. Like, this is just really, really slow. I'm not sure how reasonable it is to, how reasonable it is to assume, or like to think that 10 million operations lasting like 16 seconds is slow. To me, that is extremely slow nonetheless. So we have to improve that, and that is what we're going to focus on. I've never done a sort of, well, I guess I have, but like an optimization focus, right, where we go and we try and modify the code just so that optimization is maximized. So we'll try and do that. And for those of you in the chat that haven't done it, it's going to be a good experience because, we go at the code back and then we say, okay, right? And then we start considering other trade-offs that relate specifically to performance. And that's going to be fun. Smarts42. Hey, my favorite political streamer is online. Brother. Yeah, you guys were having a blast in the chat last time talking about politics. But yeah. So today, as you can see in the title, the title of this stream is precisely, coding a memory allocator from scratch in C, measuring performance for real this time, no AI. So the for real this time comes from the fact that I think the title of the stream was like, measuring performance for a while, but then we took, for like 2 days ago, and then we took a detour to make the arbitrary an intrusive data structure so that we could adapt it to, anything. And then we changed all the UN32s to be size T so that, the allocations would work and everything would make sense. And so now we're able to actually, run for very real this time. Yeah, basically, because I don't think we'll be able to finish it today, right? Like all of the performance measuring. But today is the for real, right? For real, because we have set up everything. The memory allocator works. We have all the interfaces working, which is awesome. And so what we're going to do, and let me actually go back and uncomment those lines. What we're going to do is, one of you a while ago recommended a way to measure our performance, or to have some sort of a benchmark, right? And that was the mimalloc-bench, right? Mimalloc-bench is a project that allows you to benchmark malloc implementations, right? So here you can read it. It's suite for benchmarking malloc implementations, originally developed for benchmarking mimalloc. It's a collection of various benchmarks from the academic literature, together with automated scripts to pull specific versions of benchmark programs and allocators from GitHub and build them. Due to the large variance in programs and allocators, the suite is currently only developed for Unix-like systems, and specifically Ubuntu with apt-get, Fedora with DNF, and Mac OS for a limited set of allocators and benchmarks. The only system-installed allocator used is glibc's implementation that ships as part of Linux's libc. All other allocators are downloaded and built as part of build-bench-env.sh. If you're looking to run these benchmarks on a different Linux distribution, look at the set of packages, blah, blah, blah. Another reason to prefer Linux, right? It is quite easy to add new benchmarks and allocator implementations. Please do so. So hopefully we'll be able to connect our own implementation of malloc to the mimalloc benchmark. And thank you, Dan, for this. So we'll see if we can actually do that. Note that all the code in the bench directory is not part of mimalloc-bench as such, and all programs in the bench directory are governed under their own specific licenses and copyrights as detailed in the README files. They're just included here for convenience. Benchmarking, right? So we get this script, right, which builds all of the allocators. You can benchmark them, etc. It says mimalloc and tcmalloc on cfrac and Larson with 16 threads. Generally, you can specify the allocators, right, and the benchmarks, or all the allocators and tests. Use this much to set the concurrency, and use help to see all supported allocators and the benchmarks. So current allocators, right? It's a list of all of the allocators that exist, or at least they can be or have been tested in mimalloc. Not maybe they didn't use the mimalloc bench, but the mimalloc bench tried it with these and compared results. So current benchmarks. The first set of benchmarks are real-world programs, or are trying to mimic some, and consists of the following. So Barnes is a hierarchical n-body particle solver, simulating the gravitational forces between 163,840 particles. Uses relatively few allocations compared to cfrac and espresso, but is multi-threaded. Okay. So one thing we have to have in mind is we do not allow for multi-threaded things. We can definitely implement that. We first, I think it is better if we first improve our single thread implementation so that we know what things we actually need to solve. And once we have that in mind, we can proceed to multi-threaded, which I think it's not going to be that difficult given the principles that we already have in place. Yeah. Jazz Lean N, the Lean compiler. Interesting. Okay. The second set of benchmarks are stress tests and consist of okay, simulation intensive with a Pareto size distribution. The alloc test and benchmarks run on n cores doing this much. Whoa! 100 million allocations per thread, which objects up to 1 kilobyte in size. Dang, that's a lot. But anyways. So, there's a security benchmark. Yeah, that one, that's what we want from. So below is an example of April 2019 of the benchmark results in an HP Z4 G4 workstation with a 4-core Intel Xeon W2123 at 3.6 gigahertz with 16 gigabytes of ECC memory running on Ubuntu, blah, blah, blah. So we get the pictures of, there you go. So it's Barnes, Espresso, cfrac, Lean, Redis, Larson, N. So these are all of the tests. I'm not sure if each of these represents a different allocator or if it just represents multiple runs. We'll see. We eventually will know. Oh, wait. It tells you right here. Oh, okay. So mimalloc. Okay, it's a little bad. The colors are not the greatest, but it's okay. I think you can kind of distinguish what's going on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bars. Okay, so each bar corresponds to this. mimalloc seems to be beating absolutely everyone. That's absolutely insane. And great, too, for them. Jiggle bytes. What? What is that? Anyways, um, so we take a look also at this, and it seems like mimalloc also achieves a very good performance when it comes to memory usage, although it's beaten by the rest sometimes. But damn, mimalloc is like absolutely incredible. What? That is kind of insane. Wow. It always stays on the... Oh, this is different. This is relative RSS. Okay. Perfect. All right. Results and notable usages. So it seems like, ooh, it's been used in other papers to test all the memory allocators. Okay. I think this is exactly what we want. We definitely need to... Okay, what is the license? Let's see. Permission is hereby granted free of charge to any person obtaining a copy of the software and association documentation files to deal in the software without restriction, including without limitation, the rights to use, copy, modify, merge, publish, distribute, sublicense, and or sell copies of the software, and to permit persons to whom the software is furnished to do so, subject to the following conditions. The above copyright notice and this permission notice shall be included in all copies or substantial portions of the software. Okay, that's totally fine. So let's clone this repo. I assume that's the way we do it, right? We clone the repo. So let me terminal. So I imagine we go to CD projects, and then what do we do? I think I'm gonna RMRF the malloc copies. Malloc copy 2, malloc copy 3, malloc copy 4. Perfect. One thing I do want to do is like push this. I think we're up to date, but yeah, okay. Perfect. So now that we have this, I think I'll try and clone. So let me clone that. Git clone this guy. We should be fine. So it's cloned, and thus we enter cd mimalloc-bench, and then I'm just gonna open code on it. Yeah, okay. Here, let me manage. Trust. You trust this folder. Perfect. So let's bring it up to the second workspace. And then increase the font size by a little. There you go. So that you guys can see better. So, where do we start? It's a great question. So, let me inspect. Okay. So you have all of this, right? The benchmarking, right? The build bench and .sh. Will automatically pull all needed benchmarks and allocators and build them in the external directory. It starts installing packages, and you will need to enter the sudo password. Although the programs are built in the use this guide to see all options. Okay, so let's see what this allows us to do. /build bench environment .shell -h. So let's see. We have these many options. So we have all to set up and build almost everything. Number of processes. Okay. Force, reclone, and rebuild for given tools. Okay. So these are, set up these allocators. Let's sudo blah, 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 blah. Okay, so these are the benchmarks, right? Bench, build all the local benchmarks, set up Lean3 benchmark, set up the required packages, set up Redis benchmark, RocksDB benchmarks, and the Linux benchmark. Okay. Okay. So can we, if everything succeeded, you can run the full benchmark suite from our bench as this. Okay, I think let's try and run all of the benchmarks to see, you know, how it works. So let's do /build bench and then old. It may take some time, I imagine. If installing all the packages. Oh, is it ready? Oh, that's kind of crazy. Yo, let's go. Okay, perfect. Okay, let's reset this. So everything is in external allegedly, but that doesn't seem to be the case, right? Because we just ran the script and then not much happened. MPFR install. Oh, so it seems like something's happening. No available formula with the name MPFR. Did you mean MPFR? Searching for similarity named formulating casks. Vampire casks. So is it just not working? Seems like it to me, right? So are we missing something? What is bench sh? Okay, let's read the preview. Generally, you can specify the allocators. Use this much to set the concurrency and use help to see all supported allocators and benchmarks. Okay, so if we do /bench.sh, I imagine it's not going to work because there's nothing external. But from the out bench directory. What? Okay, so this seems to be a problem because this command is just not working at all. Yeah, so brew install dos to Unix, yes, wget, cmake, ninja, automake, libtool, gnu time, gimp, mpir, and gnu sed. Brew install mpir. Oh, should install the equivalent. Benchmarkers be left on the bench. Yeah, yeah. So right now, it is not working. So I think GMP is the thing we need to use. Not completely sure. So brew install GMP. It's already installed. Okay. Well, then why does the thing not work? Do we need to? So what do we need to do? How do we set this up? That's unfortunate because this script with the all argument will automatically pull all needed benchmarks and allocators and build them in the external directory. The problem is if you go to extern and then ls, there's nothing here, right? There's nothing in there, despite the fact that we run the command. So build bench env .sh, right? Oh, sorry, it's not here. It's // Yeah, build bench env .sh. Then it does that, but then oh, did it do it? Oh no, it didn't. Okay, well, what are we supposed to do? Oh, is it inside of bench? Wait, because I see like all of the allocate, like, whoa. Okay. So, what? Oh, these came already with the repo. Yeah. So let's see. Done in this, run the cfrac benchmarks as. It's telling me cd out / bench, but like the command didn't succeed. Because we do build bench and .sh old, and then it installs packages, and then it just goes out. It just exits. What? So will we have to change the scripts? I hope not. I really hope not. Okay, let's find occurrences of ampere, which is the one that's, yeah. So how about we delete this, because it's the only thing making it fail. And then we try again. There you go. Okay. That's probably gonna, break everything, but it's fine. Yes, proceed with the installation. All right. We're set in motion. I am kind of sleepy today, though. It's, it's the morning, and I want to sleep. It's okay. It's okay. Yeah, let's just wait for this to happen. Let's wait. In the meantime, I think we can, so we're waiting on that. We have this guy in the second workspace. And do I have it still? One. Yeah, let's play the little train game. In the meantime, as we wait for this to load. That was pretty simple. Okay, we did that. Continue. Continue. Okay, where are we now? Oh, we're there. So I think we can just... Yeah, that's easy. Too easy. Too easy. Okay, I think we can slowly but surely do this. Yo. Oh? Oh, we have an error. Oh, no. Wait. I'm already too invested. Oh, shoot. Ah. Oh, this is really bad. Why does it skip double? Oh, no. Dude, okay. Anyways, let's try and see what the problem is. All right. Oh, we have problems with... Okay, this is... So, in file included here, unknown type mutex t, unknown type name mutex t. Okay, 11 errors generated. Okay. So who is making these errors? Our malloc, right? So we can just run the command. No, our malloc. Like, I think that was the indication that they made, where they say use no in order to... Wait, where is it? It's in the readme, right? No dash or dash no, or something like that, right? I'm pretty sure. Set up packages. Oh wait, no, it wasn't the help of this thing. There you go. Prefix an option with no to disable an option. Yeah, so I guess we are gonna do no or malloc. just because we're really not like interested in other allocators, but we just want to run the thing. And I think it should be faster now that it knows that the packages have been installed. Oh my god, there's errors everywhere. Oh no. Okay, what are these errors? So it's here, right? Non-null, pthread. Okay. Does macOS just have no? Wait, no. Yeah, it should. Pthread rw lock d. Okay, so it seems like we would have to modify the source code of those files. Not completely sure. This is very this is very bad. Okay, I think we're just gonna have everything, like all the benchmarks, and we are only going to test the allocator that comes with, GCC or whatever. So die harder, garter, no, harden malloc, iso malloc, jmalloc, mimalloc. Maybe we can try and set up mimalloc. So if we do benchmark right, and then do alt T, I think, and then me, will that install only mimalloc? I think so, yeah. Okay, mimalloc doesn't crash, which is great. So let's try and build that. Let's try and run the benchmark for mimalloc, just to see what the interface is and how things should be done. Yeah. Perfect. So now we should have something called out/bench. Brother, what is this out directory they keep referring to? Done, right? And then they said run this as cd out to see all options use this. So you just run bench.sh help. You must run this script from the out/bench directory. Brother, what? Do I just create it and then I just move things inside here? What am I supposed to do? This is extremely confusing. Yeah, do we just put it there? Then we just cd out/bench and then run it here? Okay. Sure. Let's see. Da-da-da-da-da-da. Options. So show this help, be verbose, concurrency level. 1 seconds of sleep, read external allocators from file 1 per line in the format name path. So run all tests, run all allocators, run all secure allocators, and then do not run specific tests. Okay, I see. So can I just specify a single allocator? Because this doesn't say that. I see. Tests included in alt T. Further tests are these guys. Secure allocators included are these. So, okay, these options are very confusing. Like, where am I supposed to put? Okay, suppose I just want to test mimalloc. So me, right? Do I just do ./bench.sh, pass me, and then pass in the test that I want to run? Like, what am I supposed to do? I think, despite the help not being too helpful because it doesn't mention the order of the arguments, I'm not sure. Let's try and do me, and then let's do one of the tests. So I think if we run cfrac, right, this should work, right? Oh, it seems like it did. Oh, that's great. Okay, let's see. What is the output of this? Allocator me tests cfrag. Run one cfrag, so it does this. And that's cfrag permission denied. Oh. Okay, so do we have where is cfrag living? Do we know where cfrag is living? Where is the file that they're trying to run so that I can give it execution permission? Malloc test cfrag. Is it here? No. Is it building it somehow? Like what are we doing? Guys, this is so confusing. Like what? How am I supposed to use this? Like yeah, so okay, bench data sage. First, it doesn't generate the out/bench folder. It also doesn't do it. Like, what am I supposed to do? Maybe ls. Is there like a cfrag in there? I mean, I guess so, but it's not being. There's not like an executable, right? So how am I supposed to give it execution permissions? Okay, maybe not cfrag, maybe something else. Maybe alloc test. There you go. Alloc test. Is that better? So it just generates this guy, right? But it's completely empty. And of course, everything is gonna be 0 just because, you know, there's no, it's permission denied. So what am I supposed to do? Because it tries to run alloc test, no? But that is not even a program, that's a folder. So if I try to do alloc test 1, of course it's gonna, right? Because if this was some other thing. Ooh, okay. Can I just run chmod plus x on this? Yeah, no. Like, this is a directory, but am I supposed to just compile this? How am I supposed to use this thing? This is extremely... Okay, so let's try and run bench again with alloc test. And then, of course, it just says, yeah, permission denied. Yeah, does anybody know what we need to do? This is really confusing. For now, let's just continue with this. Let's try and find happiness for a few seconds. There you go. Yeah, I don't... Oh, shoot. They crashed with us. Okay. We failed. Maybe we can try and figure it out how to run mimalloc-bench on macOS. Because the problem might just be Mac. Still mimalloc on macOS with ports. No. I want... Yeah, so we just... See, now I'm confused. Hmm. Build them in the extern directory. Yeah, so if I try and do this, if I go here, extern has, right, all of the things, that's great. And so then, if everything succeeded, you can run the full benchmark suite from out/bench as this. But then if I try and do that, right, if I try and do that, it seems like this bench.sh doesn't, should it be there? Should it be here? Reset. So what is my current directory? Yeah. So if I try and run this, I get just zeros everywhere because nothing's running since nothing has permissions. Like, see, permission denied, permission denied, permission denied. Is there anything that is just not failing? Oh wait, it seems like this guy got to run. Who is this? Was it mimalloc? Me sec. Okay. And it seems like it actually ran, right? Me dbg, mimalloc debug. So that one got to run. But I want the, not the debug version, but the actual, you know, full-fledged. Yeah, dot slash, does your terminal have privileges? Great question. Like, I tried giving privileges to the things themselves. I am very unfamiliar with the Mac terminal mod. Like, I'm not sure what to do to give it permissions. So, do you guys maybe know? Let's see. How to give sort of, I'm not sure. It's not the same as Windows, but administrative privileges to macOS terminal. And by the way, um, by the way, Vendetta RXI, welcome to the chat. Careful not to lock your device. Yeah, exactly. That's like, that's what I'm saying. So should I just run sudo on it and then it'll work? Like, I know, you know, people often advise you like, oh, don't do that. Yeah, same. Like, and also Linux would be like way simpler. This is just, you know, this is just dragging it. I don't, sudo maybe on this, 1, 2, 3, 4. If I run sudo and then pass in only mimalloc and then the alloc test, did it run? Yeah, no, permission denied. So like, my thing is, this thing is trying to execute alloc test, but alloc test inside the out/bench folder is not an executable. It's a folder, right? So what are we doing? Like, huh? Our Apple are obsessed with how you experiment with their devices. I don't even know why people get Mac at all. Yeah. It's unfortunate. Like, I looked it up and it says you're gonna run VS Code as administrator. Okay, but then, because I guess that implies that we would have to go here and then simply run, you know, pseudocode dot. Right? Like, that allegedly would make it administrator, but I don't think that's gonna change, right? Because it's still trying to execute a folder, unless I'm unaware of the way things work and like folders can actually be executed somehow. Like, if we just go into out/bench, right, we reset. And then we run the command again. Yeah, everything fails again. It just says, oh yeah, permission denied for this thing. Which again would make sense since that guy is a folder, not even a file. So if I try and go back, right, and then I somehow do ./bench and then I pass it some argument. So bench is something that's not supposed to be a program. It's just the name of a folder. Would I get the same error? Yeah, permission denied. Yeah, so it's just trying to execute the folder, but that cannot run. Am I supposed to compile this thing? If so, wouldn't they have a make file for it? Yeah, I am, if anything, like, I don't know. So am I supposed to maybe do... Yes. You just saw me do it in the terminal. Pseudocode dot. Like, and like, even if I do it here in the terminal, right? Like, it doesn't seem to work. Chmod plus X. Yeah, I tried doing that, but like, I don't think you can chmod a folder. Right? Like, maybe we can try, but you know, and then try again. Like, there you go, right? It just doesn't work. No, on a shell script. Yeah, like chmod is a command, I think, in Mac OS. I don't remember exactly, but if I remember correctly, and everyone please feel free to correct me, it is to grant executable privileges to whatever you're doing so that, you know, the macOS can actually execute it. But like, tried it, yet it doesn't work. And of course, like, it's not gonna work because it's a folder. So why? So maybe we have to run cmake here of some sort. No? Maybe like cmake something? I have no idea. Okay, let's just be guided by intuition. So if we do this, right? If we move this folder outside of here, right? We move it. And then we eliminate out. Because out sounds like it's the result of some sort of build. So maybe, only maybe, right, we have to go inside of bench. cd // is going to tell me there is no such thing. Reset. And then maybe if we enter bench, then we're going to say, well, how about you cmake? And then the source is going to be this folder, and the build is going to be // out / bench, right? Maybe that makes sense. They're expecting us to build the thing out, and then the bench folder here. Bench. What's the folder? Well, the folder is alloc test, right? It's a folder here. But I think let's try this out. Okay, build files have been written here. So we have the bench one, but there doesn't seem to be anything inside of here. Yeah. So, oh no. Let's see. How about we try this one, right? We cd into // out / bench. Then we make cfrac. So we built cfrac. And so now that cfrac is a thing, maybe we can now run the program, because now it's not a folder, it's an actual file. So sudo /bench . And instead of calling it with that, we call it with cfrac. Oh, it's stalled, which means it's running, I suppose. Yay! Okay. I think that was it. I think that was the good intuition. Let's see. Results written to benchRest.csv. Interesting. So cfrac, and then it just gives us random numbers, which I'm not sure what they mean. So we have the test, the allocator, the time it took, the RSS. What does RSS mean? What is RSS in the context? Memory allocators. Okay. In computing, resident set size is the portion of memory measured in kilobytes occupied by a process that is held in main memory. Oh, okay. Sure. Let me first go and refill this water bottle. I'll be back. Well, I guess you guys can still hear me, right? I'm here trying to fill the water bottle. All right. I feel they should have told us that we needed to do that in the repo. No, and the README should just say like, oh, you just build them yourself and then run them, because it's otherwise confusing. So we'll see. I mean, I'm about to be back. Don't worry. All right. I'm back. Guess who's back? Back again. All right. So. Let's see how we can run this, and let's see what these numbers mean. So RSS, right? Is it measured in kilobytes? Is it measured in, wait. Okay, there you go. Measured in kilobytes. Okay. So if we go back, turning 2,464 kilobytes. So that'd be 2 megabytes. Well, 2.4 megabytes. Then user 4.55, sys5, page folds 88, page reclaims 410. So the time is just 5 seconds to, milliseconds or, femtoseconds. But okay, now it was a little faster. Okay, so it seems like we just run in like that, right? I feel like. How about we try with a different one, right? Maybe we can try with, let's see. What are the options? SH. Test included in Alt T. So maybe we can do Alt T on mimalloc. So let's try and do that. This and then Alt T. So cfrac runs first. Whoa. It's a lot. Ooh, it seems like these didn't get to run. Oh, of course, because... Yeah, never mind. They haven't been built yet, right? Wait, no, see? It's building Larson. It built Larson. It also built the X-malloc test. So what are we talking about? Why wasn't that happening with the others? mleak, malloc large old. Yeah. It's building them all. Did CFrag get a... Yeah, see, CFrag got an output. So it means it worked. I guess we'll wait. Alloc test 1. See, alloc test. So it built alloc test 2. Okay. Let's see what the output was. About to run thread 0, joining thread 0. Oh, perfect. See? So it seems like alloc test does work. What's the benchmarking library called? It's called mimalloc-bench. You can see it here in the top left. mimalloc-bench. So yeah, we're trying to run all of these things. Xmalloc test 10. So let's see. Do we have the results? Yes, it seems like we do. These didn't get to run because they have 0 time. I think mstress also didn't get to run. But you can see how others, like say arpt, wait no, like Lua did get to run, right? 43 seconds, 14 seconds, 39 seconds. Yeah, okay, so now we have a summary at the end on how much time each of them took. Yo, perfect. Oh, command exited with non-zero status, command exited. Okay, these guys seem to be working fully well. Lua, alloc test 1, and so on and so on. I guess like one thing we can do is maybe run multiple allocators. What happens when we run 2 of them? Can we compare them with each other? So let's try and enter the help of this thing. And then we also have a system allocator. So let's try and see how mimalloc, for example, compares with the system allocator in all the tests. Is that a thing we can do? Yeah, it seems like it recognized it. So maybe not all the tests, right? I'm gonna cancel this if I reset. So let's run it with CFrag only. Okay, the system now does it. So mimalloc took 8.191 seconds. Ooh, the system took a lot longer. Let's see the results. So if we go to CFrag, we should be able to see, okay, so this is what it outputted. So both of them outputted the same because of course it's the same program, but mimalloc took like way less than the system. So the time is this. So I guess the thing we care about is time, right? I would imagine, of course. And so let's try and put our allocator here. So it's a great question on how we are going to do that. We have to investigate. So what is it that we have to do to put it here? What's your allocator called? It's we call it nmalloc. Well, sorry, nalloc. Here you can see it on the top left. Is malloc just with an N? So yeah, it's this whole project. And we're now trying to measure the performance, right? So now we need to investigate How do we add a new allocator to mimalloc-bench? Maybe in doc? Oh no, these are all the images they had on the GitHub. Okay. Because it's funny, like, because they say, right, it is quite easy to add new benchmarks and allocator implementations. Please do so. But they just never tell us how. So it's a little, I don't know. Anyways, we're kind of left in the dark here. Yeah, I'm not sure what to do. So let's see. What do these guys do? So it calls alloc tester, right? Um, oh, so it seems like, okay. So redistribution of source code must retain the above copyright notice, this list of conditions, and the following disclaimer. Redistributions in binary form must reproduce the above copyright notice, this list of conditions, and the following disclaimer in the documentation and/or other materials provided with the distribution. Neither the name of the organization nor the names of its contributors may be used to endorse or promote products derived from the software. Yeah. The software is provided by the copyright holders as is. Da, 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 da. Can we use this is the question. Or tort or as in any way. Oh, it seems like we can. Okay. Perfect. And this is C++, yes, but you know, doesn't matter. So was it just me or did they finish Allocate a couple of streams ago? Yeah. Yeah. So we finished Allocator like technically we had like a minimum viable product like 2 streams ago, right? Something that worked. And that could be considered an allocator because you could just make calls to malloc and free. However, like, you know, as many as you wanted. Then last stream, we converted our data structure for the red black tree into an intrusive data structure, which Andrew, it was either you or Stricknid who suggested to take a look at intrusive data structures. I read about them and then we implemented the red black tree as an intrusive data structure. And so now, you know, the allocator is finished in the sense that like it runs, right? Correctness is there. Now we want to like benchmark it. We want to see like, is it fast? And if not, how do we improve it, right? Because personally, I've never done that for like a specific program. Yeah, exactly. And so what we did was precisely that, right? So we went and created a red black tree that was an intrusive data structure because I read it like a few nights ago because you know you mentioned it like a while ago and better late than never. I said I was going to read it, so I fulfilled my promises and I ended up reading about intrusive data structures, and I said like, wait, this can be perfectly applied to the project, and so we just made the red black tree an intrusive data structure because the red black tree was like fully bind to the allocator, like you know it was making use of the internal state of the allocator. It would like, you know, read blocks and so on, which is not ideal if you want something that can be reused. And so the intrusive data structures, when I read it, I was like, oh wait, this is the solution to that problem. So we did that. And yeah, that's it. And we have the like the little fuzzer. So yeah, so correctness is there, right? If we compile and then we do this guy, the fuzzer, you know, say for 10,000 operations, then it just does 10,000 of them, 100,000 the same, right? And it doesn't fail anywhere in between. So we are, in a sense, you know, we are to assume that correctness is there. Or at least we've tested it enough to have a high degree of confidence. Now we're benchmarking. And the problem is, like, we're also using the mimalloc-bench, which I don't remember if it was you or Stricknit or who specifically suggested, like, oh, whenever you want to benchmark it, this would be a great repo to look at, right? So that's what we're doing right now. We're trying to fight mimalloc-bench because the documentation doesn't specify how to add a new allocator. Um, it's just, we're trying to figure it out. Hot take, linked list as an extrusive data structure is never useful. I'm not sure if that would be a hot take. Like, I'd say having discovered intrusive data structures only like 2 nights ago, I would say I'd perhaps agree. I think there would still, it makes it a simpler mental model maybe to just have it be extrusive, but I would say I agree. But yeah, um, I just peeped your linking, bro. You're cracked. I'm trying to no, bro, bro. It's you have not seen actually cracked people. Like, um, I'm still in college. You can like most of my experiences are just from college, right? So you can take a look at that and you'll see that it's really not that much. Um, yeah, I will accept the compliment if we ever finish this memory allocator and we make it be fast. But yeah, because that is our only goal in life right now. People, this memory allocator, we have to test it somehow. The problem is this thing is not working. Like, how am I supposed to test it? Because it like, you know, it anyways, because we have in the extern, right? We have the projects. So how are we supposed to, you know, how are we supposed to run it? Finish something impossible challenge? Yeah, it's the rule of thumb for every single programmer. Finishing no personal projects. Um so okay, what does the project need so that it can be tested with mimalloc-bench? Um Let's see, what does bench.sh do in order to, you know, execute the mimalloc thingy? Whoa. Okay, mstress, no, these are the tests. I want the allocators. Oh, shoot. I think I missed them. Where are they? Oh, they don't, where are they? Wait, alloc run. I think it's these, right? Mm-hmm, mm-hmm. So run a test. Okay, how does it run a test? It grabs something, it does that, and then pre-process, clean or lean, Okay. Sure, it just tries to specify the file to which it's gonna write and where it's about to build, I guess. And then there is no way that you close switch statements a case with an SAC. That's insane. Okay. It's like the if and the fee. Yeah, there you go. See, that's so funny. Anyways, um, let's see. So with Redis, security. No, we want, brother. What do I need to do to run? Yeah, we're gonna die here. Trying to see. Okay, for alloc and alloc run do. Yes, yes. Contains alloc then. Set allocator lib to point to the allocator.so file. Oh. Ooh, okay. For test repeats, do in the case of alloc in sys da 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 da. Bye, penguin operator. We'll see you. It seems like it just runs run test env cmd with this. So what is alloclib? Which I think is the important thing here. Yeah, because then it does this, and then it allocates that guy. But where is he defined? Alloclib set alloc. Okay. And so what do we need to do? Yeah, what huh? What does this do? Because how do the tests know what the allocator is? Like the name of the allocator? Or does it just replace the already taken name of malloc? Is that the case? Maybe we can read. Let's read cfrac. Oh wait, never mind. Okay, that's too long. How about we read alloc test, I suppose. So when they called right the allocator, what do they call? Malloc? Is the word malloc anywhere in here? No. So how? Okay, let's try and go to alloc test. Maybe we can take it. You know, what year are you in your degree? I am in. So I just finished my third year, so I'm going into the fourth year. To test TC malloc, make sure new delete allocator is selected as selector.h. See useful build notes at section testing. Yeah, this is not very helpful. How? Brother, I'm losing all hope. I'm losing hope, like slowly but surely. Marinka Wee Wee, welcome to the chat. Yeah, because how do we do this? How do we test our own? The guy just went in and he said it is quite easy to add new benchmarks in allocator implementation. Please do so. Sure, but like how? Right? Oh yeah, it's quite easy. It just like doesn't explain anything. Has to be somewhere, right? I would have just finished fourth year if I didn't drop out. Ooh. Andrew, is there a reason you dropped out? Did you go maybe and pursue something better? Was it problems? If you feel comfortable talking about it, I imagine. But brother, what is this? What is this? Selector.h. Maybe selector is the to do. Include my allocator.h. Define my allocator T properly and make sure other inclusions and or definitions are removed or commented out. Yeah, but it seems like the script does all of this automatically, right? I don't think I'm seeing double. I think. Okay. Add executable cfrac to the cfrac sources. Oh, what is M? Oh, M might be the thing we're looking for. Ooh. Because it's like, it's linking everything against M. M might be the secret key. Oh, never mind. Hmm. Mm. Mm. Hmm. Does it build a file called M? I don't think so, but there has to be a way in which we can do these. Espresso. How about espresso? Oh God, no. Yeah, no, it's very long. Same for CFRAC. Barnes, maybe? No. Okay, do we ever use malloc somewhere? Like, how do the tests know what to run? And it seems like everything is just in the shell scripts. Nowhere else. Yeah, what do we do? Brother, what do we do? What are we supposed to... Hello? This is very annoying. What do we do? Okay. Vendetta says, I'm going into third year in September. Yo, wait, you're still, it's pretty early. But no jobs or internships. Yeah, that's completely fine. I never got an internship up until this point. So you're on the right path. Best Reaper 21, welcome. Welcome to chat. My dude, it is Wednesday. Okay. um What is that folder? So, Best Reaper 21, we're currently trying to benchmark our allocator. The problem is, the authors of the mimalloc-bench were so friendly that they didn't include instructions on how to add your own memory allocator. I imagine it is something easy to do for somebody that has the experience with built systems and everything like that. Unfortunately, I do not. So now we're angry at them. Because we don't know how to use this. Yeah, so CMake files, cfrac there, build.make, build. Yeah, brother, what are we doing? CMake files, make file 2, and then cfrac. CMake files, make file 2. Brother, that does not even exist. What are we talking about? Make file 2. What? Hello? Barely any docs and a lot of unclear stuff. Yeah, it's more like, we have the README, right? And the README just sort of explains the reason of being for this guy. But then it says something, this phrase, it is quite easy to add new benchmarks and allocator implementations. Please do so. Enjoy, Dan. So, he's like, oh yeah, it's pretty easy to add them. And then he just doesn't tell you how. It's like, so like, I don't know what we're supposed to do because there's a bunch of allocators. So one of my questions is, how does a test know which allocator to run. Do they have a common sort of symbol, some sort of thing, right? Say malloc. And then we link against the allocator who defines what malloc is. In this case, it would define it to be their own allocator. And so now when the program runs and it calls malloc, it actually calls their allocator. So I am not sure at all. And it is concerning. So yeah, exactly. The same thing, right? There would be some specific symbol, and then you just replace those symbols, or you link against your own library, and then everyone is happy, right? But in bench .sh, right? Bench.sh, we have. Let me see what we can do. So we have. Let's understand what is going on, because we do the node type, right? Darwin time at CMD. libc check directories, sure. Then the allocator library paths. Ooh, wait. May this be the solution? So what is it that we're doing? The allocator library paths. So allocator library variable and then library path. So what is the library path? Great question. I have no idea. Alloc lib add. Wait, guys. We might be onto something. So you need to add the allocator library, right? And then, okay, so it seems like each of them defines a library file with a .so extension. So let's take a look at a folder. So say I go to here to me, and then we go inside of, let's see, for mimalloc, where is that? For mimalloc, it's in me/out/release/libmimalloc dilib. Okay. So is XSO not dilib? Is it instead? Sorry. I thought it was .so because it says .so. Oh, it's dilib. Ooh, okay. So, dynamic library for macOS. Oh, I'm stupid. Okay, yeah, of course. So we compile as that, and then we just link it against it. Like, yeah, I imagine that now the guy, this little bench shell script, links it against the actual thing, and then everybody's happy. So now the question becomes, what are the name of the symbols supposed to be? Like, am I supposed to export things being called malloc? Or how am I supposed to do this? I can pack general purpose allocator with excellent performance. Yeah, thank you, brother. But what? Let's see if we can figure it out. Let's see, because it has to be a common symbol that everybody knows. The only one that exists is malloc, but maybe there's something else. I mean, this is the out folder. Let's see src, right? So if you go to alloc.c, page malloc, page 0, is there any mention of malloc in this file? Like standalone malloc? No, they import malloc. Right? And so maybe in the include. Oh, wait. This is the interface, right? This would allow us to know the interface. Standard malloc interface, yeah. So we have me decal no discard me malloc. So they still define them like this: me malloc, me calloc, me realloc, me expand, me free, Mr. Dupe, Mr. No Dupe, me real path. So maybe there is some sort of macro or some sort of thing that you just have to. Oh, is it the mimalloc override? Aha! There you go. There you go. It may be this, right? Right? Because then you just override. Let's see. This header can be used to statically redirect malloc free and new delete to the mimalloc variants. This can be useful if one can include this file on each source file in a project, but be careful when using external code to not accidentally mix pointers from different allocators. Aha. Okay, I think we found the solution. So it is indeed what we thought it was. I'm not sure if this is what is intended to be used, but then I want to know what is this new delete. Oh, of course, for C++. Okay. Provides convenient overrides for the new and delete operations in C++. This header should be included in only one source file. On Windows or when linking dynamically with mimalloc, these can be performant than the standard new delete operations. Okay. And so now what we need to do is, so first of all, let's verify that that's indeed the case by checking that everyone does this. Do they all do an override? And is there, okay, because my problem here, it's like, the leave me malloc dilib or whatever, that should not include the overrides, right? Because like it's a dynamic library and maybe you're like, you wouldn't want it to interfere with anybody. So lib me malloc the dilib, right? And the rest do the same. So GD, for example, right? GD is another one we have here. GD. Yeah. And so GD doesn't actually have anything. So, well, to give, credit to them, I don't think we compiled it correctly. Also, we only have installed the me malloc guy. So I think, let's see. Let me read the chat. I suppose. What's the name of the benchmark? It's mimalloc-bench. I suppose maybe malloc knowing it's used the most of the time. Yeah. Seeing there are malloc that are theirs, I suppose it's using malloc free. Yeah. So your allocator needs to export malloc free, calloc, and realloc. Yes. I would say so. I think most of them just use malloc, realloc, and free. I don't know if they use other things like calloc and stuff. Like we may have to implement those. I really don't want to do that. Average documentation in a lib when it's precisely what you need. Yeah. So I think we just need to write these override headers, and then this is what we maybe. See, now I'm starting to doubt. Because this thing, where is it? The dynamic library, this guy, right? Isn't it supposed to be sort of the final product or like, like the final product. And so you wouldn't expect your final product to just override malloc, right? Because you don't know what the user wants. So I'm confused on like, right? Did they just override malloc or was it just, let's see. Then we have a warning, then we have a contains, allocator move, allocator add remove, is installed, tests run add, tests run remove, read external allocators from file, test run add. Options. Show this up. Okay, yes. So suppose somebody specifies a given allocator, right? What happens with them? So allocators, it says this, and then it tries to do, what does it do with them? It goes, it doesn't use them for a while. So to run a test, right? It runs the test environment CMD. Then it echoes this much. It clears the temporary output, whatever that means. Then we have the out file, the in file, sure. Case 1. What does that even mean? Do we know what this means? Like, why are we... I imagine this may be just the first argument, but what does it mean to have the case of the first argument? Oh, this is a switch statement. Okay, if it's lean, if it's mathlib, if it's Lua. Okay, I see. So these are not with respect to the allocators, right? Yeah, it seems to be fine. Make it clean. Ta-da-ta. Why don't you just write your own benchmark? We could do that. The thing is, one has to be very careful when writing a benchmark to make it like actually comprehensive, right? Because it is very likely that we just end up, making a benchmark that actually doesn't reflect the way programs behave in real life. And so that's what sort of, leaves me hanging. And I'm like, man, come on. So yeah, that's the reason, right? We use something that has been, tested against like actual things, and we know it's a benchmark that works. It is better if we use it. Plus, we're able to grab a standard and know how our allocator behaves with respect to that standard, rather than some random thing that we don't even know what it compares to. So, yeah. So here, these are just like, okay, run test CMD. Let's see. For alloc in alloc run, for every single allocator, then if it contains then we set the library to be this. Yeah, so .so file, which is the dylib thing. And then for each of them, we say if the allocator is system, then run this. If the allocator is this, then we do this. If it's TBB, we say this. For the rest, we do LD preload, whatever that means. And then we put in the allocator library. Okay. So what is LD preload? Okay. The only reasonable thing to assume is that they expect us to replace malloc and that the program will use it. So I think it's safe to go with that assumption. And then the dynamic library will just, put it there. Because I honestly cannot explain to myself what you would need to do. Because make clean olean Lua, right? It enters the Lua dir, then it make cleans, and then it just goes out, right? And then here it seems like it starts the actual things, but I don't know. Because here it's Redis, right? Then there's security. And then the rest are done like this. Benches the line, ta 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 ta. Alloc fill. What is alloc fill? What is alloc fill? Because it could be like, you know, fill these definitions to be this. Oh, okay. Well, alloc fill user env in file then out file. Because it seems like it's running. Okay, what is time CMD? Do we know what it is? G time. Okay, so I imagine this is just the thing that allows you to measure the time. Then what are we timing? We're timing this, and then bench fill, which is that much, and then we passing what, the first parameter? Then the second parameter, which would be fine, I guess. Yeah, I'm not completely sure. Let's just try and assume that, right? Let's try and assume that, and if it doesn't work, then we see what happens, but okay. Okay. Oh wait, no, people, no. I just remembered there's something that we haven't done in the memory allocator that we actually need to do. Yeah, I know. Yeah, I know. I felt you all. I'm sorry. I completely forgot about that. Memlib, right? Memlib defines a couple of things. So notice, for example, to expand the heap, we call mem sbreak, but this is just like a little toy thing that we did at the beginning so that it would, you know, we could expect the heap and everything. Like this is not the actual system calls to, you know, expanding a breakpoint or shrinking it or doing anything like that. So now we need to do that. Now we need to actually replace the mem sbreak thing with the actual thing. Yeah, so the reason why this was there at first is because I didn't really know how to do it. And so we just put that there. I'm back. Hello, Penguin Operator. So let's investigate. How can we write something to expand the heap? So how to use sbreak in C. Can we use sbreak? Okay. System calls, we have this. Oh, please, no. Okay. Yes. There you go, here. Yes. Break resets in the heap of the process is a simple task. Location of the program break. Since the memory that lies past the program break is an allocated memory, we can move the break into the unallocated memory to allocate some new memory for a process. There are two functions associated with this process. The location and then sbreak. So can we just do provide an increment of 0 to sbreak? When an increment of 0 is provided, the current break address is returned. If you provide a value other than 0 to sbreak, you get the previous break address, meaning the address before the break was changed. We can see this effect using a few increments in a row. So I think we can just use the normal sbreak system call and we will be completely fine, it seems. Yeah. Yeah, I think we'll be fine, right? So we can do this. Okay, let me read the chat. Do you guys know any way to read and write process memory without the kernel's permission? Um, I don't. I also don't think that is possible. Like write process memory as in another process different than yours. Debuggers can, I guess, but like, I mean, I guess so, but like if you're saying like without the kernel's permission, it seems like you don't have control of the other program, cannot establish some sort of program, because then it would be like a really bad security issue, right? Like if there was indeed a way to write process memory without the kernel's permission for a process you don't control and cannot communicate with, then it would be like like really bad. So I would assume just for that argument, no, it's not possible. But I have absolutely no idea nor experience. So yeah. All right. People. We need to implement this S break guy. So memory break, I think we can just do wait, it returns the address, the previous break address, meaning the address before the break was changed. Yeah, okay. Address before the break was changed. So if we just do old break is equal to S break. Oh, it seems to be deprecated. S break is deprecated. So what do we do instead of S break? Does it just not, you know? Will it just not let us? I'm completely dumbfounded. No idea what happens. I think if we just do this, then we can do S break 0. Then we have memmax address is this, and then OG size. Yeah, perfect. Then here, when we do memd init, oh yeah, we don't care about this. Or like, well, I guess we do, but like we just comment it out, right? And then, and then this is it. I don't know. I guess this is done after the check. But yeah, anyways, so is this it? Is this the only thing we need to do? I think so. So if we do, well, I think this is gonna fail miserably, and then yeah, okay. It's gonna give us the warning that like SRIC is deprecated and all of that. I know, but will it still allow me to use it? I am not sure. Oh, it seems like it does. Great. Let's go. We got away. Because now if we do standard lib, malloc should only be imported in the tests. Oh, shoot. It imports this too? What the hell? Why is it there? Okay. mm.c, it should not be using the standard library. Why are you importing that? Stevec can do that because it needs malloc. Fuzzer.c, yeah, sure. An arbitrary test, yeah. So now only the tests import anything that could relate to malloc, and it seems that everything's still working. So now if we run this, we should be able to see a great Okay, it's working. Great, great, great. Okay, perfect. Give me guys 1 second. All right, I'm back. I'm back, and you know, reinforce better than ever. So, okay, we're gonna have to figure out what to do, right? Because things are not looking great, right? Amazing B-hop. He put some what I assume to be Mandarin characters. I'm not sure what those are. Hello. I see. Yeah. So yeah, we're currently trying to run a benchmark on our memory allocator, and we have to figure out how to make things compliant with the benchmark. Um, I think like right, this dynamic library probably just does that. And okay, now from now on, you'll see my inexperience shine because I don't know. Also, now that we replaced the call to S break, it's like actually really slow because we made so many syscalls. Um, that's so funny. Anyways, it's okay. It's okay. It's okay. Don't worry about it. We'll follow one. So let's let's revert time and take a look at this. Right? If we compile again with what we had previously without using S break, we're just using sort of the little toy S break that we had. All right. We're gonna run the fuzzer with 100,000 operations and sort of take a look at how long it takes, right? It's like 1, 2, right, like 1.5 seconds. Like runs 3, 4. Okay, 1, 2, 3, 4, 5. Never mind. I was trying to prove a point, but actually, never mind. It seems like that's not an issue. Um. Oh shoot! What happened? Oh, okay. Then if we bring it to the actual S break, then you know, it seems like to me it seemed a little slower, right? Like it definitely is a more like slower. 1, 2. 3, 4, 5, 6. Yeah, no, it's way, way slower. Yeah. Anyways, I managed to port the allocator tests to my OS. They also managed to break them because of janky changes. Oh well, pretty good. But yeah, maybe you can help us with what the hell we need to do to put it here. But anyways, I think okay. What is once again, guys, don't burn me at the stake for not knowing these things. We're here to learn. It's the reason. By the way, we got okay. Actually, let's run a game of this. Yeah, score of 1. Oh shoot! What was I not supposed to do that? Okay. Anyways, let's run a 3 is no shame in not know. There is no shame in not knowing something. Yeah. So we're gonna play a little, for some time because the mental fatigue that's about to take place. Oh, brother, you don't even know. What? What are you talking about? Okay. Ah. Anyways, okay. Let's do this. We gotta reach 10 somehow. So let's see. Can we? I think we can just like border this guy. I think that's the strategy. To not allow the game to have any spaces in which to put a card. Oh shoot. Okay, that. Yeah, there you go. So now we can go like probably like oh shoot, I didn't see the one below. Nah, it's fine. Okay. Let's see. This one I think we can just do this. Yes. This one I don't know why my right key is being pressed. It presses it twice. What the hell? No, this is so unfair. What? No. No. LGTM. Oh wait, I forget what that means. I forget. Let's go to the moon. I don't know. Looks good to me. Oh. Yeah, this is not looking good because because then this train is gonna come. I think it takes a lot to come here, which means that we'll be able to surpass it. Yes, we were. Oof. Okay. Pretty good. Where is the cart now, brother? Oh my god. So we have an issue here that like this other train is gonna come out and it's gonna, dude, this is so unfair. Okay, so if I go up, then I need to go to the side because my previous version is gonna try and catch me. Then I need to go here and then escape. No way we escaped. Oh shoot, no. Dude, this is what I'm saying about my right key just pressing twice. See, now we lost. Okay. Anyways. I hate that game. Okay. Let's actually be serious. Okay, what is a dlib in my card? So what I imagine it's like something that is just linked at compile. Sorry, that is linked dynamically when you're about to run the program. So it is linked. It adds symbols to it, and then now you're able to call those symbols, right? Right, analogous to DLL file. Yeah. So let's take a look at what. Oh, we have a iPhone. Why is the title of the page iPhone? iPhone. What is the deal in? What? Okay. Um, I'm developing an iPhone app. Okay, yeah, that explains everything. And working through some sample code I saw, which uses libc, dlib. I did some research and found nothing enlightening. Other than that, this thing could be used for zip files. Okay. A file ending in the extension dynamic is a dynamic library. Yes, it's a library that's loaded at runtime instead of at compile time. Makes sense. If you're familiar, wait, jailbreak related. Oh, yeah, it's good. Let's see. If you're familiar with DLLs from Windows or DSOs, it's more or less the same type of thing with a few twists. Okay, that makes sense. Covers all the details about the format and what you should be aware of. Okay, let's read that. Apps are rarely implemented as a single module of code because operating systems implement much of the functionality apps need in libraries. To develop apps, programmers link their custom code against these libraries to get basic functionality, such as the ability to write standard output or draw complex images using a graphics card. However, linking to libraries creates large executable files and wastes memory. One way to reduce the file size and memory footprint of apps is to reduce the amount of code that is loaded at app launch. Dynamic libraries address this need. They can be loaded either at app launch time or at runtime. Dynamic libraries provide a way for apps to load code when it's actually needed. Okay, so now it makes way more sense. We need, like, why we would need to, overload, in a sense, malloc. Because then the dynamic library just gets imported, and then the symbol, like, there is no requirement for the test file to include some sort of special thing. We're just going to force it upon them. Right. To load dynamic libraries at runtime. Yeah, okay. Okay. No, this makes sense. So let's see. How to make my C file a dynamic library. So creating delib from C source at the command line. Perfect. I think this is exactly what we need. Let's see. Bro, I'm cooked, says Fambier. I played 38 out of 40 levels of my favorite game, and now there's no more content soon. Wom wom. Sorry, no. No. I mean, dude, wait, that's sad. I mean, you still have 2 levels though, so maybe, you know, you can enjoy those 2 levels knowing that there's nothing beyond. It speaks a little bit about life, no? Enjoying life, even the last seconds, knowing that it eventually has to end. Very interesting philosophical takes. Anyways, context. I have downloaded the source code for a discount. Okay, simple C program. What I need. I want to turn this code into a dlib file that I can then bundle with my Cocoa app. Once I have the dlib file, I'm fine. What I'm struggling with is how to create. This is so okay. Probably somebody in the comments were like, actually, your question is not related to this thread and whatever. Before you yell at me, yes, I have Googled my ass off, but I cannot find a straightforward explanation of exactly what I need to do at the command line. This is so funny. Everything I come across is convoluted or talks about building a delete project in Xcode or is outdated. I see. Make install. So from what I gather, run in this vehicle, make install is supposed to put a delete file into user lib. That does not seem bottom line. Once I've downloaded this with source code, what do I need to do at the command line to create a delete file in macOS? Thank you. Let's see. That project by default doesn't create a dynamic library on macOS X. I made a quick patch to Makefile that seems to work. bro just pastes the oh no. Okay, so it seems like they modify the Makefile and then the Makefile does. So it seems to be specific to this project, maybe. I think if we just read the diff, we'll be able to know what to do. Diff of this index, da da da, solved everything, da da da. So yes, we have this. So it adds Markdown and it adds also mkdlib. God knows what that means. Like, this is the least helpful answer in all of Stack Overflow, bro. What do I need to do at the command line? And then just proceeds to say, oh yeah, I patched I patched everything. You can download the product again. What is the command? What is the command? Yeah, okay, that's... I know, we could have read the diff, I suppose, like... Okay, maybe we can just go to the original project, actually. If it's a GitHub... Oh, never mind. Well... Well. L flags. So where is L flags defined? It's just not defined. Okay, that's fine. That's fine. How can I convert my C code into a library? Reddit posts are like one of the best things. So I made my own implementation of a stack using a linked list, and I would like to reuse this code for a different task. I would just import the code and continue working, but this is not possible in C, or at least I haven't figured it out. Oh, can't you just do an include? Online, I found two options. Either compile and run my code by adding the stack implementation code in the compilation step in the terminal, or I turn my code into a library by making a header file and a normal C file, which allows me to include my stack implementation similarly to how I include this. Yes, okay, but does this relate to a dlib? Yeah, first there is an implementation made up of C files. This contains the actual code for functions and stuff. This is compiled into a library, either static or dynamic. Yeah, what you want is a static library. A static library is linked in the final library. No. We want a dynamic one. So this question is not for us. I feel the question is pretty clear. How to make my C file a dlib? Maybe we can take a look at this. Okay, I do not trust Facebook, but this is such a weird place in which to post a question like this. Like, brother, what are you doing posting this question here? Oh. Yeah, okay, this is useless. Does anybody know how we can generate a dlib? Oh, there you go. Can I easily create a dlib from a collection of header files? Yo, I have limited experience with C++. They just gonna figure this. Yeah, you have to edit stuff in CMake lists, maybe. The thing is, like, our project doesn't have CMake, right? Because we didn't set it up. We didn't really have the need to, right? We could do it with CMake, but then that means we need to set it up and everything. I'm pretty sure there needs to be some sort of thing, right? Like, this has to be because in the end, CMake runs just commands, right? Malvar7sp clang dash shared. Okay, so as I'm saying, like, this is where my inexperience shines. I have absolutely no idea. So what would the steps be according to what Malvar is saying? So we just use the clang compiler, and then we just do clang, then we compile as usual, and then just do dash shared. Let's try that out. So we do memory.c, only the C files, right? The header files don't have a need to be there. mm.c. All right. Then utils no, arbitrary.c probably. And nothing else, right? Yeah, I don't think so. So only those three. Memlib, and arbitrary. And then we do dash shared. Oh, sorry, yeah, src. Yeah, src slash this, src slash this, src slash this. Right. I guess it says src is containers slash that. Src, yes. Okay, and we also need to include, which I'm not sure how clang does it, but do we just do -I and then include the folders that we want? -I src, -I lib, -I include, just like we did in the makefile, right? Oh, it seems like it is. Great. Oh, wait. Is a.out the dlib? Like, you know, like, is that the guy? Is this it? Wait, how to create a dlib file with GCC. How to build a dlib from several this. Oh, it seems like dynamic lib flag does the trick. Okay, interesting. I think we can just use that. Let's go. Maybe we can create a dlib here. Dlib, right? And then we just depend on all of the stuff that we have. So we have src/memlib. We also have mm.c. We have /lib/containers/arbitrary.c. Perfect. So now the command that we need to perform is, I guess we can call it like build/release. like if this was a real project, they would just like create the release folder. GCC. So we need to GCC this into a dynamic lib, apparently. We put in all of the targets that we're doing, and then the output would be stored in build/release/ and then we put in, the name that we want, .dlib, and then we do the flags and stuff. Right? Is this it? I think so, right? Seems to make sense to me. How about we do make dlib? Yes. So release is created and then we have dlib. Oh yeah, we don't need the debugging symbols. Let me just, make clean. Perfect. Oh shoot, what the hell happened? Oh, okay. I was so scared. Make dlib. Okay. We built. Now we have release and we have the dlib dot. Oh. Yeah, whatever. We just do, maybe we do nalloc.dlib. That's a better name. Make clean. Then we actually make the dlib. Perfect. So now we should have it here. So the only way we can actually test this is by oh wait, let's see the chat. So Smudge Ferrier, hello, welcome to the chat. I was wondering if you could help me with my project I am working on. Depends, like, right? I'm not sure if I have the expertise to do it. We could take a look at it, or you could ask questions. Yeah, it really depends. Tell us what your project is. But yeah, in the meantime, let's continue here. So I guess we can just create the dynamic library, right? And then we can sort of, before even talking about mimalloc, we can just create a new folder and write a very simple program and try and link it with it to see if it works. Right? I think so. So how about we open a folder? Then let's see, projects. Then we have this. I want to create a new folder that's just called tests for projects, right? And let's just create, another folder. And then, no, let's just write some, well, actually, no, rename. Simple C program. Perfect. And so now what we could do, right, is just write a very simple program. Manage, trust, bye-bye. Okay. So something like main.c, right? So what we can do here is maybe we have an int main, then a return 0, right? And then what can we do after it, right? I don't know. Maybe we can allocate an array that just has numbers and then we print the numbers. That sounds like a good idea, right? So then we can do hashtag include stdio, I think is the name of the yeah. And we can run something like, I don't know, int nums is equal to, and of course it's gonna be an array, is equal to malloc. Sorry, there you go. Malloc however many bytes we want. So size of an int multiplied by, you know, maybe 10 elements. And then we're just gonna do for int I equals 0, I is smaller than 10, and then I plus plus, well, plus plus I. We're gonna continue. This guy goes here, there's a space in here. This guy, we're just gonna do printf hello, and then we just append what number we're talking about. Of course, it's always the new lines. Yeah, that sounds about right, right? And so now I wonder, can we rename our functions to be called, oh God, what happened here? What? It's like a graveyard, bro. What? Oh, wait, did many of these make use of... Maybe? No. Okay, so there is a problem with the header file. mm.h file not found. Brother, what do you mean? It's right there. The thing compiles. Okay, this thing is just complaining because it likes to complain. Do you have... Let's see, what's the project I can help maybe? And then Joao Santos. Welcome to the chat. Do you have any advice for juniors? So what do you mean with juniors? Juniors as in college or juniors as in like high school? Or what specifically? Yeah. While you answer that, I'll try and link these things here because they are not making much sense. So what's happening to our header file? This guy is like completely paranoid. Memly.h file not found. Brother, it's here. What are we talking about? Why do you say file not found? Anyways, unknown type name node t. Brother, we're importing it from the red black tree. Okay, reload the window. Was the delib the LSP breaks? Yeah, probably. But like, that'd be a little odd. But I think you're right. Let's see. Let's wait. If it fixes itself, great. If not, I'll just, yeah, okay. Yeah, let's just ignore it for now because it's not important. How about we define like, right, extern void star malloc, and then size t and then size. And then we do the same here, extern void free, and then we have a void start pointer. I just saw a message in chat. Give me a second. I'll take a look at it. But for now, oh, brother, what happened? Oh, okay. Void star and realloc. Sorry, not and realloc. It's only realloc. Yeah, realloc. Then we have a void star pointer and a size t size. Right? Perfect. So we define those, and then here in our actual implementation, we just implement them. by saying something like, actually, I'm just stupid. I'm stupid. I should have just renamed the files. I don't know what I'm doing. Yeah, I could just rename this to malloc, rename this to free, and rename this to realloc, and then do the same in the C file, and we would be like more than happy. Malloc, yeah, replace all of malloc with malloc. Replace all of n free with free. And then replace all of n realloc, which should throw, yeah, with realloc. Perfect. We have it. Okay. So that should be fine, right? Right? And then what we can do is we can try and build. We make the dlib. Okay, no errors it seems, which is pretty good, right? Excellent. And now, look, now we can link that against an actual program. So let's copy this. Let's go here and let's paste our dlib here. Now, how do I link things? So how to link a dlib when compiling GCC macro. Okay, by the L flag. Sure. Okay. Right. Let me see. Wait, no, but this would be like statically link it, no? Yeah, no. So know that DL open is not the only way to link. You can also use -L. You don't need to mess around with DL sim. Okay. So do I use -L and that's all I need to do? Compile dynamic. Give me a second, guys. I know there are messages in the chat. Give me 1 second. 1 second. So that... Oh, this is Java code. Okay. Oh, wait. Build the dlib. Do you see this? Install name. So do we compile? Wait. Link dynamic library in GCC. Dude, the question is not that difficult, Google. What? What is going on? Is the image file -L.so? Okay, what worked for me was this. GCC-L dot, and then... So when we need to... Okay. So we just do 2 paths. Okay. Let's see. -L and then path to file containing library. And this guy. If I have a library named libmine in home, then I do the following to link it to my program. There you go. Oh my, this guy is like an absolute Chad. It's absolutely incredible. Let's go. Let's go. First, okay. So it seems like if your library... So if your library starts with lib, then mine should be the name you provide, right? So let's test this out. So if I do GCC, right, main.c, then I pass in the big L to be the current folder, and then I pass in the little name to be, oh, I guess should be named libmalloc. It's to be malloc. And then I output everything to, I don't know, main. We should be fine. No. Okay. Well, call to undeclared library function malloc with type do not support this implementation. Yeah, so do I do that before doing this? No. Okay. Does anybody know what I'm doing wrong? Or is it just not finding the library? Oh, sorry, this is the wrong. Yeah, what's happening? Why? Or does dash L just need to contain the full name? As this guy puts it here. So dash L, two dots, libmalloc.dlib. No. I'm not sure what to do. How to link a dlib when compiling in GCC? The question is really simple. Yes, we've done this. We've done this. Method 1 link using the dread path. Like, we've already done this. Yeah, see? Like, what are we doing? Right? Like, or do we just do exactly that? Like, do we just forget about the flags? And then just say that? Dot slash this? No, brother, what is going on? Like, do I need to make a change of sorts? Like, what is the problem? Because libmalloc defines the correct sort of implementation of malloc now. Or do we need to include some sort of, extern here? Like, will that help? I have no idea. So void star for size t. So void star malloc, then say size t. Will that help? And then we reset. And then we just... Yes, it seems like it works. So if we run main, library not loaded, malloc.dlib. Reference from here, reason tried. Oh, I think, okay, because I changed the name. So maybe we can do it this way? I'm not sure. Let's try it out again. How about we put libmalloc in. Sorry, it's called malloc. And then we actually run main. Brother, what? What is going on? Does it really just take in, like, is it required to be in that folder? Why is it specifying, like, specifically that it should have just linked it before, no? I imagine. And call it malloc.dlib. Okay, maybe not like that. Maybe like this. Malloc.dlib not found. Brother, it's right there. What are we talking about? Huh? Okay, I'll read the message in the chat. In the meantime, maybe some of you can let me know. Let's see. Getting started in the market. Just JavaScript, PHP, MySQL, and WordPress. I'm pretty sure rebuilding resets to compile commands. Oh, yeah. I got a lot of people talking about Python, C#. What kind of apps are you building? Yeah. Websites only right now. Oh, okay. Yeah. Pretty sure. Oh. My question is about the future. So, Ja, like, can you clarify maybe what your question is? Do you mean like you don't know what to do in the future? Do you mean you may be worried about, what is it that you're worried about? Is there like you say you somebody, oh no, maybe that wasn't you, right? What specifically, is the thing that worries you? Is it, oh, maybe I don't know enough? Is it like, oh, I don't think I'll get a job in the future? What is it? Like, let us know like what it is that you're concerned about. Maybe we can talk about it. In the meantime, hopefully you are also concerned with these dynamic libraries because they're not cooperating. Um, Not found. Okay, but the previous one did work, right? Well, we just said this. But then it just tries to do a bunch of weird stuff. And then it like, completely fails. Anyways, how about, instead of doing this, we just build, there should be no problem, right? Maybe if we do it like this, dash O is just nalog delete, and then it won't insert the random thing in the middle where, yeah, then we just copy this, then we go to the second thing, and then we delete. Then we paste. Perfect, that should work. Okay. Then if I run main, brother, I'm gonna kill you. Okay. Oh, I'm not going to kill you. It's actually executing the thing. That is pretty crazy. So I think that what we need to do, if I remember correctly, yeah, I forgot to do that. So we depend on this thing called the init, which I don't know why we have. But like we thought we would use it, but actually we don't, right? Well, we kind of do, I guess, but yeah, we do it for this. For the red black tree, we where is it? We cannot default initialize it, and so we rely on init to make it a null pointer. Right. I think for now, just to see if linking works, I'm gonna create an extern void init. Right. And then just call init here. Yeah, there you go. So if we do everything again, and then we run it again. What's going on? Okay. Yeah, what is happening? Why is this failing? I also have to go soon because it's about to be 10 a.m. and we need to end the stream at 10 a.m. You're saying, I'd like to know which language is best for the future or one that will give me more opportunities. Ooh, that is a difficult question. So I have, it is difficult, at least for me, because as I've said multiple times in previous streams too, I don't have much experience with the workforce, like, when it comes to what is the best language currently, because I'm not working. I would say, it it is difficult to tell, right? In one sense, I could tell you like, don't do web, but that is like such a general thing, and like it doesn't make sense. Yeah, I unfortunately cannot provide a specific answer. So what I can tell you, and let's use these last 5 minutes for that because I gotta go. Okay, I gotta go at 10. It is unfortunate we didn't get to link it, but you know, we'll see. We'll see. I'll try to figure it out in the evening or something, so that you guys don't have to, you know, see me just debugging this over and over until it works. But yeah, so Java basically, right? Um, I don't think there is such a thing as the language that will give you opportunities, as in like the language. Because of course, right, there's many needs, there's many businesses, there's many places where things are used, right? So I could tell you, oh, learn Rust because Rust is, the frenzy right now. But that would, that would only apply to certain types of jobs, to a certain industry, etc., etc., etc. I think the question you should start with is, what do you want to do? Because that dictates very well what kind of thing you want to learn. So, for example, I like a lot low level things, or maybe not low level, but like things that imply, being or like difficult problems related to low level things in computers. So, in that case, for me to learn JavaScript would be completely unwise because I'm not going to use it. And despite the fact that learning languages, it's pretty good, right? I would be better off focusing my efforts on learning something else that's more related to this. So in this case, I would learn C, C++, right? Rust, Zig, etc., etc. Maybe Go, right? And so really start from that question. What is it that you want to do? Once you have that clear, it is now your turn to say, okay, right? What languages should I learn? And usually when you have an area you want to focus on, that decision is very clear. There is many languages out there. So if you just approach that first question, it's going to be difficult. But suppose you say, oh, I want to, dedicate myself to web development. Well, now it's pretty simple, right? You just got to learn TypeScript, for example. There is not much of an option. I want to learn low level. Well, C, C++, Rust, Zig. It's mainly those. Um, I want to do, I don't know, formal verification. Then you know that you have to use Daphne, Rock, etc. So that the area is going to dictate what you learn. If you're sort of, um, yeah, if you're worried about that. After you decide on a language, I think the best course of action is to simply pick a project that you think is interesting. Because rather than learning for the mere sake of learning, which could work the first day, but then you slowly but surely lose the motivation as you go, it's better if you just grab a project, right? Do something, right? Learn by doing rather than watching just YouTube tutorials, which, like, you should watch YouTube tutorials as long as you follow the tutorial and you write code too, right? And I feel that would be the way to start. That would be the way to direct yourself. Because I mentioned this because it seems like, you were asking like what languages should I learn, etc., which leads me to think maybe you haven't learned as many languages or stuff like that, or you're unsure what you want to do. Yeah, I know it's a bit general, but it is a little difficult with the information that we have right now to respond to the question in a more detailed way. Um, so let me read. Da-da-da-da-da-da-da-da. Let's see. Pixel del Twitch. Pixel del Twitch. Oak. Program in C without AI like in 1965. Interesting, yeah. We have Pierito 95 RSNG. If I may share my opinion, I'd say it depends on which niche you want to focus on. But if you ask me which language would give me a long and stable professional career, I'd recommend Java, C Sharp, and Go, though. As I said, that depends a lot on what you want to work on. Yeah, pretty good. So Pierito, it's a pretty good and valid opinion. Um, See, I don't like Java. I hate Java with all my soul. So I'm not sure if I would include Java in the list, but yeah. So what Pierita is saying is an iteration of that idea, right? Look at your niche, and then that will tell you which languages to learn. But yeah. All right, people. it's 10 a.m. And if you remember, we gotta end the stream at 10 a.m. I gotta go now. I'm really sorry, guys. We didn't get to link the thing because for some reason one of the assertions isn't working. I don't know. We'll have to figure it out. We'll have to see. But until that moment, which will be tomorrow. So the way things are going to work is this, right? This little guy, this little demon of a D-lib or whatever this is, if I can even call it as something, because it should be in the darkest pits of hell. We're going to treat it with a lot of care. We're going to treat it with a lot of love until we get it to link with an actual program and we actually get to use it. Once we achieve that, we can run the mimalloc-bench. And then we'll be happy. And so today, we've been working on that, yes. But I don't want you guys to be waiting for me to figure out how to link a library to see what's going on. So what we're going to do is I have to finish stream now. And I'll take a look at this in the evening, try to figure out what it is, that we need to do, how to link the libraries, because the code is already there, right? It's probable that I won't write any code. If I write some code, I'll tell you guys like what modifications I made. But yeah, once we deal with this little guy and this little toy program works, then we'll proceed to the next thing. And oh, wait, we're not even using whatever we allocated. I'm stupid. Okay, there you go. There you go. And so, yeah, so that's it. That's what we're going to do. And yeah, in the evening, I'll try to see what happens. Because currently, it compiles and everything, but when you run it, there's like an assertion. I don't know why it fails. So we'll have to see what happens. And yeah, all right, everyone. It was great to see you today. I'll see you guys tomorrow. I need to get a haircut too. Peace out. Bye bye. Good luck with your day. We'll see you tomorrow, 7:15 PST. As usual, we have stream tomorrow. We are gonna discover what happens with the linked library. Today in the evening, I'm going to be working on this. So tomorrow, better expect that thing to be fixed. And we're going to run the malloc bench. Bye bye.